About 4, maybe 5 months ago, I bought a well positioner. I always call them a turntable, and I've had plenty of seat time in front of a turntable. Where I used to work and where I retired from used to have the big floor models. I mean, really huge. That could, no telling how much weight they could hold, but I sat in front of them quite a bit during my trips to the fabrication shop there at the shipyard, and I'm no stranger to it. But about 4 or 5 months ago, I bought a little small version of that, something that would sit up on a table. And at any rate, I want to do a modification to it. It's got a through hole through the spindle. The model I have has a through hole, and you could push an argon line through there and purge your pipe. Problem is, the pipe is constantly turning. If you got a tight seal, that argon line is also spinning with it. And on the back of it, it could actually start twisting up and potentially get kinked and cut your flow without you even realizing it. So I gave it some thought, and I've come up with a plan to counteract that, to where I can spin over and over and over and never have to worry about my argon line getting kinked or all twisted up. So let me pull it out here, and I'm going to show you what I've done up to now. All right, here's my turntable, or well positioner it's also called. And what I did is I took this back plate and I unbolted it from the spindle nose right here. And before removing that, I had to remove the chuck itself. This will take up to 8-inch pipe on this particular one. And like I said, this particular model has a through hole through it. But what I done is I took some 1-inch aluminum stock and I turned this down to the diameter of this hole. It's a slip fit. I didn't have to press it in or anything. It slip fit. And I also bored this thing out to I think it was 33/64, which is the exact same size as a stainless steel pipe that's going to be coming out of here. And it's just, I didn't want to, you know, a interference fit. I want a slip fit on this pipe. And this is more of a slip fit as far as the bushing goes, so I end up using Loctite 603 retaining compound. And let me tell you, 15 minutes after pushing this in here, I could not budge it. And really the only way to get that out of there is to heat this up to around 500 degrees to where it softens that, then it will come out. I have no reason to ever take that out. Now after that, I went ahead and figured I need one on the back end. And I'll show you this in a minute when I get this thing turned around. But I wanted a bushing on the back and coming out the front to where it's really running true with no slop in it. All right, I just took some acetone and cleaned these pieces very well. Now this is the bushing, the 1.5-inch bushing that I made, and this is going to have a tight fit, and you know it's going to have some interference, not super tight, just enough to where I have to bump it in with like a dead blow hammer or a ball peen hammer, whatever the case may be. I wanted that a little bit snugger, and I still will be putting that Loctite 603 on there. Now this center hole here, that's exactly 33/64, which is the exact same diameter. This is sold as 1/2 inch, but it's a tad bigger than that. So I did not want any interference. I want a slip fit on this. As you can see, there's no, I mean, very little movement there. That's a good tight slip fit. I did that so I can position this exactly where I want it, where it's going to end up. Then I'll mark it, I'll back it up, and I'll add this Loctite 603 on there, and that'll lock that in permanently. That way, when everything turns, this pipe and everything will turn with the turntable. Now this is a swivel. This is actually made for air. It will hold back 145 psi, which as a purge, we're only dealing with cubic feet per hour, very low pressure. I mean, you can turn your argon up kind of high at first to push all the air out, then you choke it down to where you have just barely a little positive pressure, just enough to keep the air pushed out. And as you can see, this spins on this swivel here. These are clean, so I'm going to go ahead and put this in place. Let's do that now. All right, this is the Loctite 603. Do not confuse that with the thread locker. You do not want to put this on threads because you probably ain't going to get it back off unless you heat it up. It takes about 500 degrees to turn this stuff loose. So what I want to do is go ahead and take my bushing here, and we just want to apply some. Rub this in with my fingers. Want a good coat on this. And this bushing here really don't need this because, like I said, it's going to have some interference. Now this stuff will not set up as long as it's in the air. That's why you got to have a tight fit anytime you use this. So let's go ahead and put it in place here. There you go. See how that's not wanting to just fall in like the front one did? And there's that one. I actually left that 3/1000 oversized. It really should have been pressed in. I don't have no way to do that. But that ain't going nowhere. Now hopefully I haven't changed the diameter of that hole. Yeah, I have. So I'm going to have to drill this back out using a hand drill, using that same drill bit. There we go. That's what I need. I need to be able to slip in and out. That's still a really tight fit. So that Loctite 603 is going to work very well on that. All right. All right, so this is a back cover that was on this unit. It's held on by 2 screws here and 2 screws here. And I'm just wanting to see where I want this thing to finish off at. And right now, that coupling is butted up against the bushing. And I'm thinking that's about where I'm going to have it. All right, so let me put a mark. I already know that this is just going to butt up against it. And I know I got to coat about 1.5 inches of that Loctite this way. And over here, I'm just going to put a mark right here at the very end of that coupling. To where I know I got to go back a full inch here. About 1.5 inches here, about 1 inch here. Coat it with that, push it back in, let it set. It will not move. I'll show you that. All right, so this is the front bushing. Need about 1 inch worth right there. Let's rub all this in. Now we need to go about 1.5 inches. Yeah. All right, now we can push it in place. I will not be able to get this back out. We'll let that sit for about 15-20 minutes and I'll show you what I'm talking about. All right, so I've got this piece of aluminum right here. This is the same aluminum that I used on my last video where I drilled this center hole. This is a 1 inch and a 1/16 hole. And that's going to go over the hole that you've seen on this one right here. This is a little bit bigger, but this is still going to give me clearance. That's the biggest angular cutter I had, is 1 inch and a 1/16. So I've got to attach that to this. So I'll be attaching it with some 1/4 bolts that's got a 20 pitch on them, 20 thread pitch. So I'm going to drill these out to 5/16. That'll give me 1/32 all the way around the 1/4 inch bolt to give me clearance on that if needed. Got my drill press set at 900 RPM. We're just going to pop these out. Tell you what, let me get it center first. That should be it right there. All right. I've already reamed this hole. I'm just gonna deburr these two holes right here. Alright, so I went ahead and got this hole centered with this other hole, or center enough, just where I can't see any of the edges. It should be close. That's not really important. You won't see that back hole when I'm done. Right now, I've got this actually goes on the front side, but I wanted this laying flat because of these edges. I wasn't able to do that, so I'm doing it like this. Now I'm going to take, I've got 2 different sizes of these. I'll be using a small one. This is a self-centering punch. See a little bevel on there? These are pretty handy. Just take and push it down just like that. Dead center. I don't have transfer punches, so I use this pretty much on everything. Like I said, I got 2 sizes for bigger holes. Dead center. So what I'm going to do, I'm going to be using some riv nuts to attach this to this. And I need to drill this 9mm hole here and here in order for that rib nut to go through. So let me get that set up. All right, right about there. Let's go ahead and lock this thing down. I don't feel like getting cut up today. Do the other side. And there we go. I've got a rib nut already installed on this tool here, so pop it in here. And there we go. There's the back side of it, as you can see. All right, let me get this other one on here. All right, there we go. We'll tighten that down once we get everything put in place here. Actually, I'm gonna go ahead and do it now because we got to go ahead and get this situated, figure out the rest of this. All right, so that's looking pretty good. Now what I want to do is show you real quick my plans. I was trying to figure a way to where this could not spin and just be locked in, because this ain't coming out. And there's not much friction there, but there is enough friction for that lightweight hose where it could possibly still turn it. So I found this on McMaster car. It's got an ID of 3/4 of an inch, which is exactly what that is. That'll slip up on there. So tight, snug fit. There we go. So I'm gonna measure and I'm gonna cut this, true it up with the belt sander. And then I've got some 1/4 inch aluminum rod. I'm going to weld it to here. And of course it's going to go in straight. I've got to cut these off right where I need them at. And then once I do that, I'll probably pull all this back off and actually drill and put a set screw here. Drill and tap, put a set screw. Doesn't really need it because like I said earlier, this rod is in there. It's not coming off. This is just something to kind of lock this in with. It ain't gonna take much, you know, I mean, it turns easy. But that's my idea. So I'll probably just do a quick time lapse with this just to kind of help shorten this video up some. I think I've explained what I'm getting ready to do. Now let's do it. Well, there you go. That is it. And I'm not going to put a set screw in this because this thing ain't going nowhere. It's got all of this nut right here. And I did take a file and I flattened right here where this screw head is and here, just so there wouldn't be any kind of interference on that. And as I said earlier, this thing ain't coming out of there. This ought to work perfect. What I want to do now is put the back plate on it and go ahead and put the chuck on it, and we're going to give it a try. All right, here it is. This is the argon hose. And if you'll look, it goes all the way to this double flow meter right here. That's where I purge. Now, I would have a clamp on this if I was actually purging, even though that goes on there pretty tight. Probably don't even have to. But anyway, that turned out great. Everything about it looks good. It's riding in the center. All right, now let's, I got this foot controller right here. You can see that turning, but yet you don't see this turning. That's what all this work was about. The argon line stays completely like it is, and from there in, everything's spinning. Walk around to the front. I went ahead and put that silicone purge plug on there just to kind of show you. Just imagine that shoved into the end of a pipe, and of course it would go all the way up inside that chuck when you got ready to tighten your pipe down. So I'll soon be able to get that off of this, and over here on this table we're getting ready to buy some steel finally for this table, and I'm gonna mount this on one end down here, and I'm not quite sure what I'll do with the rest of it yet. But at any rate, appreciate you watching. I'm Russ Jones with Skill Savvy DIY.